All right, today we'll be wrapping up section 4.3. We really have all the skills needed. All the skills are in from 4.3, but today we're just going to continue to work on modeling and solving real-world problems. Okay, and yesterday we started that. A lot of times the sketches were given to us. Today, though, we're going to kind of have to come up with most of our sketches on our own. Okay, all right, so I'm just going to walk you through and guide you on setting these up and how to handle the words angle of depression, angle of elevation. So let's turn a couple pages to where we get to number 1 on these applications here. Okay, so it's page 17 here in the notes packet. Okay. All right, so the directions say sketch a picture to represent the situation, then solve the problem. Round your answers to the nearest tenth unless otherwise specified. Okay, so usually this sketch is going to involve some type of right triangle. That's what 4.3 is all about. It's right triangle trigonometry. Okay, so go ahead and read number 1 to yourself, and then I'll help you with the angle, or the sketch. Okay, so we've got some type of instrument. I mean, these are real devices that can measure angle of elevations. They're used in construction all the time. So let's just kind of show a little device here that you're looking through. Okay, it doesn't have to be fancy. You don't have to be a perfect artist, of course. So we're looking through this, and then we got the height of a tower over here that they're measuring. So let's just draw a tower. Maybe something like this. Okay, of course, we can assume towers are built at an approximate 90-degree angle. Now, these devices, they measure the angle of elevation from the horizontal. That is key. The definition of that, angle of elevation, angle of depression, is always measured from a horizontal line. Okay, so what we have is kind of a sight line. So once you draw kind of a dashed line from this device horizontally, and they tell us the angle of elevation to the top of the tower. So they're, this person is looking through this device and recording this angle of elevation to the top as 27 degrees right there. That's where we place this. Okay, now keep in mind this instrument, this surveyor's instrument here, is 1.5 meters above the ground. So this distance from here to here is 1.5 meters. So that does transfer across too. We got to understand that. It's from a horizontal line. So this segment of the tower from here to here is also 1.5 meters. Okay. Okay, so a surveyor is 100 meters from a tower, so they paced off this distance to a clean 100 meters. You can put it underneath or above, whatever. This is 100 meters. Okay, so that should help you get going. Like I said, I want to focus on just these sketches in the lesson and let you finish. So what you would have to find is they're asking for the height of the tower. So I can find the distance from here to here. We'll call that X. Just remember at the end, you got to add that 1.5 meter segment as well. All right, so once again, you always ask yourself, how are these two sides related to the angle? Opposite and adjacent. We should be using tangent here, okay? All right, so tangent of 27 degrees. I'm going to stop and let's move on. You'll come back and finish that. Okay, take a moment to read number 2. I'm going to pause for a moment, let you do that. See if you can get a sketch going for this, and then I'll help you put in angle of depression. This sometimes is very commonly done wrong, so I want to give you a chance to maybe do it wrong so you can learn from your mistakes. So try to create a little side view again, like I'm doing here, of number 2. Go ahead. All right, so here's my beautiful sketch. We got a lighthouse, we got a boat. Here's where the mistake is made, putting in the angle of depression to the boats. That is measured from the horizontal. All right, so if somebody's up there at the top of the lighthouse, using a device and measuring this angle, it's going to be from the horizontal again, now going down. So here's kind of the sight line triangle we've got going on here. So when they're measuring this angle to that boat, that wasn't very straight, sorry about that. There we go, it's a little better. So there's the sight line. The angle of depression has to be from here down. Students very often want to put 13 degrees here. There's no horizontal line here. There's a vertical line, but by definition, angle of elevation and depression start from a horizontal. Okay, don't mess that up. All right, now if I wanted to create this other triangle, I could. I just have to do 90 minus 13, okay, and create 77 degrees here. And we get the same answer in the end. The work might look different, but we get the same answer. All right, so let's see. What else do they give us? A lighthouse built at sea level is 175 feet high. Since this is a right triangle, I can transfer this 175 over here. But if you're not comfortable with that, you could do 175 and then do 77 degrees here. But I'm going to go ahead and just do 175 right here. Find the distance from the boats to the foot of the lighthouse. So we're looking for this horizontal distance. It's another thing I could transfer up here because we've got kind of a rectangle if we look at it from the big picture of those two triangles together. But it's up to you. You can do this and do this. Just make that 77. Okay, so that should help you from there and let you finish it. One more sketch I want to help you with. All right, number 6 is sometimes a tough one to get going to. So let's take a look at 6. Okay, go ahead, pause and read it. Okay, so imagine some type of tent scenario or canopy. So a stake is placed 1.3 meters from the supports. So this is what they're calling the support, right? The vertical structure, maybe some type of wood pole or steel pole or something like that. So there's the support they're talking about. A stake is put down 1.3 meters away from that. And there's going to be a cord. Okay, so 1.3 meters away, we have this stake in the ground, okay, to hold down this cord. So the cord is going to be right here, right, somewhere attached to this support. That makes sense? So we got the support, we've got this cord here, and we got the stake in the ground. Okay, I'll zoom in on that so you can see that a little better. All right, some people just get confused, I guess, by those words. So there it is. What else do they give us? To secure a 2-meter support for a canopy. So this support is also 2 meters right here, 2 meters high. Okay, and then it says, what is the measure of the angle formed by the supports and the cord? Well, they're talking about the angle right in between them then. Okay, so theta would be right here, tucked in between the support and cord. This is where you got to do that inverse operation. All right, so maybe I'll help you finish this one a little bit and see if you can remember how to throw this in the calculator. Again, I've got opposite and adjacent. A lot of these applications, tangent's the one we use, but not all the time. So because I have that opposite and adjacent relationship, we should set this up. Tan of theta equals 1.3 over 2. And the meters cancel out, so you don't really have to show them, but if you did, you'd cancel those out. Okay, so remember, this is where you got to do the inverse. So pause, give yourself a chance to punch that in your calculator and see if you get the right answer. Make sure your mode is in degrees. All right, inverse tan of this gives me, they said nearest tenth, so I guess it'd have to be 33.0. So 33 points, or just 33 degrees, I guess, but I guess I'll put 0.0 since they said nearest tenth, and that shows the attempt to go to the nearest tenth. Okay, all right, that's it for today. I'm just going to have you work on all of these application problems for your assignment today. So 1 through 10 is your assignment, okay?